नमस्कार दोस्तों, स्वागत है आपका। आज हम रोलिंग मिल के एक बहुत ही महत्वपूर्ण हिस्से यानी रोल स्पीड इन एमपीएस का इस्तेमाल करना सीखेंगे। इसका उपयोग करके हम एप्रोक्सीमेट एलोंगेशन फैक्टर और रिडक्शन परसेंटेज की गणना कैसे करते हैं, यह समझेंगे। सबसे पहले यह जान लेते हैं कि रोल स्पीड इन एमपीएस क्या है। If the value of roll speed of a motor is x MPS, it means x meter length of stock enters into that motor in 1 second. यानी यदि किसी मोटर का रोल स्पीड x एम्पियस है तो इसका मतलब है कि x मीटर लंबाई का स्टॉक उस मोटर में 1 सेकंड में प्रवेश करता है। रोल स्पीड इन एम्पियस का मान एलोंगेशन फैक्टर और रिडक्शन परसेंटेज की गणना के लिए उपयोग किया जाता है। स्क्रीन पर आप एक स्काडा स्क्रीन देख सकते हैं जिसमें हर सेकंड की रोल स्पीड इन एम्पियर्स दी गई है। अब हम एलोंगेशन फैक्टर की गणना करना सीखेंगे। एलोंगेशन फैक्टर ऑफ ए मोटर मीन्स द फैक्टर बाय व्हिच द लेंथ ऑफ स्टॉक इंक्रीजेस फ्रॉम इट्स इनिशियल लेंथ आफ्टर पासिंग थ्रू द रोल्स ड्राइवन बाय दैट मोटर इन ए फिक्स्ड टाइम इंटरवल। यानी एक निश्चित समय अंतराल में रोल से गुजरने के बाद स्टॉक की लंबाई अपनी शुरुआती लंबाई से कितना बढ़ जाती है, वह कारक को एलोंगेशन फैक्टर बोला जाता है। लेट अस एज्यूम हियर L1 is equal to initial length of stock that enters into the roll in a time interval of 1 second, and L2 is equal to final length of stock that leaves from the same roll in a time interval of 1 second, which becomes the initial length of stock that enters into the following roll in a time interval of 1 second. Now we can write the formula of elongation factor, which is equal to final length divided by initial length is equal to L2 by L1, where L2 is the final length and L1 is the initial length of stock. Here, based on the screen, L1 is equal to initial length of stock that enters into C1 roll in a time interval of 1 second, which is equal to 0.466 meter. And also based on the screen, L2 is equal to final length of stock that leaves from the C1 roll in a time interval of 1 second, which is also equal to the initial length of stock that enters into C2 roll in a time interval of 1 second, which is equal to 0.669 meter. So according to the formula, elongation factor of C1 stand is equal to final length divided by initial length of stock, which is equal to L2 by L1 is equal to 0.669 meter divided by 0.466 meter, which is equal to 1.435. Now comes to the conclusion. From elongation factor we can know that C1 stand final length of stock is equal to 1.435 times of its initial length. यानी C1 स्टैंड से निकलने के बाद स्टॉक की लंबाई उसकी शुरुआती लंबाई का 1.435 गुना हो गई है। एलोंगेशन फैक्टर समझने के बाद अब हम रिडक्शन परसेंटेज की गणना देखते हैं। Reduction percentage of a motor is nothing but the percentage reduction in the initial cross-sectional area of stock when it passes through the roll of that motor in a fixed time interval. यानी रिडक्शन परसेंटेज वह प्रतिशत कटौती है जो स्टॉक के शुरुआती क्रॉस सेक्शनल एरिया में आती है जब वह रोल से गुजरता है। लेट अस एज्यूम हियर A1 is equal to initial area of stock that enters into the roll in a time interval of 1 second, and L1 is equal to initial length of stock that enters into the roll in a time interval of 1 second, and P1 is equal to initial volume of stock that enters into the same roll in a time interval of 1 second, which is equal to the multiplication of area into length is equal to A1 into L1. And also assume A2 is equal to final area of stock that leaves from the roll in a time interval of 1 second, and L2 is equal to final length of stock that leaves from the same roll in a time interval of 1 second, and V2 is equal to final volume of stock that leaves from the roll in a time interval of 1 second, which is equal to the multiplication of area into length is equal to A2 into L2. According to the conservation of volume, the volume of stock that enters the roll V1 must equal the volume of stock that leaves the roll V2 in a fixed time interval. So here V1 is equal to V2 is equal to V, implies that V is equal to A1 L1 is equal to A2 L2, implies that A1 by A2 is equal to L2 by L1. We use this relation while calculating the reduction percentage. Now we can write the formula of area reduction percentage as initial area minus final area divided by initial area into 100, which is equal to A1 minus A2 divided by A1 into 100 is equal to 1 minus A2 by A1 into 100. We can write A2 by A1 is equal to L1 by L2, and our equation becomes 1 minus L1 by L2 into 100 is equal to L2 minus L1 by L2 into 100. As per the SCADA screen, L2 is equal to 0.669 and L1 is equal to 0.446. We put the value into the equation and get the result of area reduction percentage in C1 stand is equal to 30.344 percentage. You can see on the SCADA screen the value is exact same what we get by the equation. That's how you use the roll speed in amperes to calculate both the elongation factor and the reduction percentage in a rolling mill. Understanding these values is essential for mill operators to maintain quality and efficiency. If this video helped you understand these calculations, please hit the like button, share it with your colleagues, and subscribe for more industrial insights. Do you have any other rolling mill concepts you would like us to explain? Let me know in the comments below. Thanks for watching.